Next up on our exploration of trig functions is solving trig equations. And we want to find a typical example you might see is, say, find all solutions between 0 and 2 pi of 2 cosine x equals, or 2 cosine x equals the square root of 3. And so like any other equation, what I want to first do is try to isolate that cosine of x as best I can. Well, I want to isolate x itself. So let's get rid of the 2. Let's move the 2 to the other side. Let's divide both sides of the equation by 2 so it cancels out. And we'll get cosine of x equals square root 3 over 2. And then if I want to find x, I'm going to use the inverse cosine. X would equal the inverse cosine of square root 3 over 2. Now that's one of the special angles that we come up with, but there's actually a little bit more to it than that. We're looking at where is the cosine equal to square root 3 over 2, and we actually did some of these problems in a little bit earlier. We can come up with, well, square root 3 over 2, that would be a pi over 6 angle. That's one of the special angles we've got memorized. So pi over 6 is an answer, but it's not all of the answers. If we think back about the cosine curve, if you want to think about it in terms of the cosine curve, it looks something like this. And we're looking at solving where does cosine x equal square root 3 over 2. If I look between 0 and 2 pi, there's actually two solutions. I found this one here at pi over 6, but there's another one over here I need to find at the other end of that period. I need to find that value over here at pi over 6. And we can think about it, and we can think about the symmetry, and because the cosine curve is nice and symmetric, we'll do it maybe that way to start with, is that I know that the distance from the x-axis to this first intersection is pi over 6. And that's going to be the exact same distance going the wrong way, going the other direction from the other side of the curve over here at 2 pi. And so I want to come back pi over 6 from 2 pi. Well, 2 pi minus pi over 6 is the same as 12 pi over 6 minus pi over 6. And so that's going to give us 11 pi over 6 in there as the second solution. Or another way to think about it, some people like the unit circle version of things, that if we're looking at a circle of radius 1 and the cosine value is equal to a half. Go away all that thing, whatever that was. That if I'm looking at the cosine value was your x coordinate here. If you look at any sort of point on the unit circle, the x coordinate, if your radius is 1 here on the circle, the x coordinate is the cosine of the angle, and the y coordinate is the sine of whatever angle that you're looking at, or x value there. And so what I'm trying to do is I'm trying to find the two values that you come up with in 0 to 2 pi. That's one revolution around the circle. Where are the two places where you get an angle, a value that's root 3 over 2? And I know one of them is pi over 6 because that's one of the ones I've got memorized. But the other place that you go to, well, where is it going to be? Well, I want to go all the way around to this angle. And the symmetry of the circle is such that I know that the reference angle in here is pi over 6 as well. That's why we talked about reference angles a while ago, was to get you ready for this part of it. And so I want to subtract a pi over 6, and I can come up with the 11 pi over 6 that way too. So you can think about the graph either as the unit circle or as the wave curve there to find the places where we're equal to pi over 2. We also might have some more general ones where they don't have the special angles. Where'd my scroll bar go? Give me my scroll bar. Well, I guess that kind of works. You might have, say, find all solutions to, how about sine of x equals 0.3. we'll just stay, let's keep with the same thing between 0 and 2 pi. Between 0 and 2 pi in there. So I can get my first answer using the inverse cosine, or the inverse sine. So I'm going to take the inverse sine of 0.3, inverse sine, the arc sine of 0.3, to give me my first answer. And then if I want to think on the unit circle, again, the sine is the y coordinate. So I'm looking at a y value here of 0.3. And then the inverse sine is going to give me the angle that I need in here. But there's another place, again, you're looking at a y coordinate here. There's another angle that you're looking at, and that's the angle all the way around to this point, where you've got that same y coordinate in there. The angle back down to the x-axis is still going to be the same theta. Whatever I found over here by reference angle is going to be that same theta. And so I'm going to get one of the answers would be the inverse sine of 0.3, but the other one is going to be pi minus the inverse sine of 0.3. If we're looking for the exact answers, we can also approximate those on our calculator, but we do have to get that subtract from pi to get that second angle in there. So you want to kind of think about the picture. There's almost always two solutions to any one of those, any one of the values. Sometimes you'll end right at the minimum or right at the maximum value, and there'll be only one. But most of the time, when you're looking between 0 and 2 pi, there's at least two solutions in there that you want to look for. And I'm saying at least because we're going to get to some more complicated ones where there's more questions like that. So let's go find another equation, maybe something a little more complicated. So our next question here is to find all solutions to tangent squared x minus 1 equals 0. Tangent squared x minus 1 equals 0. And so what I can do is I can, again, I want to try to solve for that tangent, get tangent by itself. This one, we got a couple of choices. Well, let's just do this one directly. Let's take and let's add 1 to both sides of the equation. So I'll get tangent squared x equals 1. And then I want to get rid of the squared, so let's take the square root of both sides. And I'll get the tangent of x equals plus or minus 1. And my goal here is to find all the solutions to this time. And so if we think about the unit circle, we can think about the unit circle here. We want to do it with the unit circle? Let's do it with the unit circle. Yeah, we'll do it with the unit circle. The tangent is the y coordinate divided by the x coordinate. And so places where the y coordinate and the x coordinate, and you look at that ratio and you come up with 1, that means the x and the y coordinate have to be the same. So that's a 45 degrees. So one of the solutions is going to be pi over 4 or 45 degrees. -1, well, I want that same value, but I want a negative slope. So I'm going to end up in this quadrant when I've got a negative slope. So that would be, that's going to be what, 3 pi over 4? Yep, that's going to be 3 pi over 4. I can also go all the way around to the third quadrant here, and that would be still 45-degree reference angle, 45-degree angle in there to keep that slope 1. And that would be 5 pi over 4. And then if I go another 45 degrees, I'm going to end up here, and that's going to be 5, 6, 7 pi over 4. 7 pi over 4, and you can keep going. You want to find them all, so we're going to keep going. So we're going to get 9 pi over 4, and so on. And so on, going around this circle multiple times. 9 pi over 4 is once around plus another pi over 4 in there. 2 pi would be 8 pi over 4. And so we've gone a little bit more there. And so what we end up with is a whole bunch of different values And we can kind of look for a pattern with it, or we can just use our period that we have. I know the period of the tangent function itself is pi, so I can do pi over 4 plus pi k, and the 3 pi over 4 plus pi k. I'm going to get two separate ones for the tangent function, one where we get the positive one and one with the negative one in there, where you get the positive slope and the negative slope. But the period is pi, so once I found one answer, if I look at things, if I look at the graph, kind of thinking of the graph this way and sort of its waveform, once I found that first answer at 1, I'm going to get another solution that is pi units away from it, and another solution that is pi units away from it. And if I go back pi units, I'll end up at another solution over here. They're all spaced because the period is pi. I know all these solutions are pi units apart. And we're also going to get values at 3 pi over 4. Okay, and this is actually a special one. We can actually, this doesn't happen all the time, but this time they actually matches up because pi over 4 and 3 pi over 4 are equally spaced. We could also combine this into just pi over 4 plus pi over 4k, and because every 45 degrees, we're getting either at one of the, no, I can't do that. I can't do that. I can't do pi over 4 because if I add pi over 4, I'll end up at 90 degrees, and 90 degrees is not a solution. I want to do I want to add 2 pi's over 4, or pi over 2. So in this case, I could combine these two into a single statement, pi over 4 plus pi over 2k, but that's actually kind of unusual. Usually you get sort of two separate answers, one for each one of those. So how about another one like that? We'll do another one. Let's take, let's say find all solutions to, have I done a cosine yet? Or have I just done sine? I did cosine up there. Let's do a sine one. Find all solutions to, come on, scroll down some more. Give me some more space. Find all solutions to sine of x. We'll just do sine of x equals, well, let's make it a nice one. Root 3 over 2, one of those special angles that we've got memorized in there. That's a 60-degree angle if you want. So we're looking at, if we look at our sine wave, if we look at the wave sort of format in there, I've got that 60 degrees. I'm looking at root 3 over 2, and I want to come back and find these two values here. There's typically, again, when you're looking in a single period and you're trying to find all the solutions, you got to find two of them. There's typically two, but then after that, the distance from this solution to that solution will be 2 pi because the period of the tangent function is 2 pi. And the solution from our second solution to the fourth solution going out is also 2 pi, and that's going to continue every 2 pi. So I need to find these two solutions and then do the 2 pi k to say that we're talking about all of them in there. All right, so the first one I know is going to be just at pi over 6, or no, pi over 3. X equals pi over 3 plus 2 pi k, 60-degree reference angle there. And then the next one is sort of that same distance back now from this one. If you look at the symmetry of this, it's kind of hard to see in my sloppy drawing, but the distance here of pi over 6 is going to be the same as the distance there of pi over 6. And so if I take pi and subtract pi over 3, sorry, the distance here is pi over 3. The distance, to my solution from 0 is pi over 3, and the distance going back from pi to that point is pi over 3 as well. So I want to subtract pi over 3 from from pi, and I'll get 2 pi over 3 plus 2 pi k. And so both of these together make up all of my solutions. If you look at any possible value for k and take any multiple of that, we should get all of our solutions in there. Okay, so that's some basic values in there. How about if we look at this last one in the unit circle? Sometimes students like looking at the unit circle a little bit better. I'm looking at the sine is equal to 2 pi over 3, and in the unit circle, the y coordinate is your 2 pi over 3. So I know that I'm looking at a 2 pi over 3 thing in there, and I need to find the angle in here and the angle going to that one. And this angle I know is pi over 6, and so it's 30 more degrees to the right triangle and then another 30 degrees past it. Or if I want to kind of go the equivalent way up, your reference angle is going to stay pi over 6 in there, pi over 6 reference angle, and so, or pi over, why do I keep saying pi over 6? It's pi over 3 as my reference angle. Pi over 3 is my reference angle. And so it would be 2 pi over 3 for the second solution, that second place on the unit circle where my y coordinate is um, root 3 over 2 in there. Those would be our two solutions there. And again, there's typically two. When we're trying to find all, you have to find the two of them and then do plus the 2 pi k in there. All right. That should get you through a few of your problems. We will give you another lesson, add a little bit more nuance in my next video in our next problem.